speaker here is going to be Michael from the LizardFS team, who's going to talk a little bit about what they've been doing. Michael.
Okay. So I'm trying to talk more about our functionality because I don't think that people really know our project. And if somebody wants to go later into how things are deft or deeper development stuff, we have a main developer here who can answer questions like that. I'm just like from the usage and administration side of things. So we have a distributed parallel file system that can do geo-replications with its distribution. We have concentrated on simplicity, I would call it like that. I mean, the basic idea is if you have tons of data and just need to set up something fast so that you can put it there, we think we have the right solution for that because it's like 8 lines of text, 8 to 10 lines of text to set the whole thing up. So I just used the example with the t-shirt. I mean, you don't go to a rocket scientist to design you a new place for your data if you just want to store things that you just grabbed from the latest FOSDEM. Yeah. Yeah, we are basically the system has 2 main components. You have a metadata server and as many chunk servers as you like. I think the limit currently is 1,024 chunk servers. You can store up to 1 exabyte of data. And the setup is very, very simple, and I will show that later in the demo. I did that yesterday, had some problems because the connectors were not working, but I can show you that. So there's basically no real learning curve. There's 1 command to manage the system. There are about 2 config files for a master and 3 for a chunk server that mostly you don't need to touch. The default configuration will do nearly everything for you. The only thing you have to do is to tell the chunk servers where the master is and where you want them to store your data. Yeah, so master chunk servers, we have options for HA on your masters. When one of the masters fail, then the one that has the latest version of the data just takes over. The switchover is very, very fast. I think we had, in our latest test, it's sub 1 second that it takes to switch over from one master server to a failover one. You can mix all kinds of platforms. We have our software available for everything that's Unix-like. So I have a setup where I have chunk servers on BSD, on CentOS, on Debian mixed. I even have Solaris chunk servers, and they all work together. So so the system is basically distributed over all of them. It doesn't really matter. The chunks are saved in a normal file system, so the performance of your chunk servers mostly depends how you set up the system under it. We mostly use XFS or ZFS for our scenarios, but it basically depends what you have and what you like. There is also an option to use a tape as a chunk server, so that you could basically have replicas of your chunks automatically saved on tape drives. Right? And as I will show you later in the demo, you can change your storage policies on the fly. So basically, if you decide that you want to have 3 copies of a file in your storage now, and later decide that those files are not important anymore and you just need 1 copy, it's a one-liner, and the chunk servers will basically reconfigure that by themselves. Yeah, and you can group your chunk servers. So basically, each chunk server can have a label, and depending how you set your policies, you can define that certain data is only saved to certain groups of chunk servers. So let's say you have 2 chunk servers with SSDs and 3 chunk servers with hard drives. You just give the chunk servers with the hard drives one label and the ones with the SSD another label. And by defining your policy, you can just, with one line, tell them where the data is supposed to be. Besides replication, we also support erasure coding. The advantage of erasure coding, besides that you have more space, is that the system then starts striping. So basically, as you set your erasure codes, your system gets parallel writes. So when you use replication, your clients will write to the first chunk server, and that chunk server will do the replication. When you use erasure coding, the way you set your erasure codes, let's say 3 data parts and 2 parity parts, it will write to 5 chunk servers in parallel. Right.
What kind of size file is that? Just supported for files with a certain size?
No. I think the smallest will be what, 128K? 64K. Under 64K, we will not cut the file in pieces. Yeah, since with erasure coding the system is parallelized, you will basically get nearly the same performance from few slow systems, from few fast systems, like from a lot of slow systems. Right? That way, it's relatively easy to have an upgrade path where you start with systems that you have, and you can at any time basically replace them on the fly. Yeah, with the labeling that I talked about, you can create some kind of basic tiering, because you can set speed labels and define where your data goes to, and that's not a replacement for auto tiering yet, but it's like a start. You can have as many labels as you want, and since the movement is very fast, it's relatively easy to create a manual tiering on your data paths. Okay, so we have a system that we developed for the master server high availability, which is based on the REST protocol and is using a quorum. The reason why we developed that is that we had quite some problems with using what was available there. There were a lot of split branch scenarios, and in general the switchover was too slow. And with our new with our new HA for the master servers, we have, in my experience, under 1 second switchover time. So if you configure your policy to be replication, your client will basically start sending data to the first chunk server, and depending on how many replicas you set, it will create a chain reaction. So when the first slice of data goes to the first chunk server, it will start replicating to the next, and so on. Yeah, until all the data is copied and all the replicas are done. That way your client basically is done as soon as he has the data copied to the first chunk server and doesn't have to think about all the replicas. Yeah, we have metadata only snapshots. So basically it's a copy on first write system. So like in a ZFS system, you would basically have no space occupied by your snapshots, and we have no limits on the amount of snapshots right now. Cool. The system has, when you add disks or you add new chunk servers, the chunk servers will try to balance out the space during write operations. And yeah.
Optional?
What? The auto balancing?
It means that if you're balancing, like removing some of the redundant information that you have in the other files.
No, basically if you set that you want to have 3 copies of every chunk, it will still keep 3 copies on 3 different chunk servers. The point is it will try to have the same amount of data on the amount of drives and chunk servers that you have. It's not, unless you use labels, it does not stick to certain chunk servers. So you can set a policy of 3, have 20 chunk servers, it will always keep 3 copies, but it will not tell you where. So it will distribute and auto-balance the data so that all your chunk servers are utilized in the same way.
For a given object, how do you figure out where it should be?
That depends if it's replication or if it's erasure coding. If it's replication, I think it's round robin. No?
How do you figure out where an object should land?
You can either have, if you have it undefined, it will try to balance out by space, right, and busyness of a certain chunk server. If you have labels, then it will go there where you defined where it should write to.
So for instance, if I had object A, it makes a hash modulo the number of disks, and it will land on a disk. That's the idea. It's hash-based placement if you don't specify otherwise.
No, it's not just, there are no labels at all, just random. Create this chunk file, goes somewhere. In a way that you like easily balancing. So if you have 1,024 nodes,
Yes.
it looks through all the nodes until it has this chunk.
Oh no, the master server knows where the chunks are. So if you want to read something, just ask the master server, then get the server where the chunks are, and get this information. And you're done. You don't look it up.
Yeah, you don't speak directly to the chunk server. You speak to the metadata server first, and that will tell you where to find your chunk. Yes.
Can you just, is there any method that you can start that let's say, oh, I want to take
I can show that.
2 nodes, because I'm just like
It's,
taken away.
it's pretty easy. You just, in the chunk server, you have a definition file where you specify the directories where it's supposed to save its data. If you put a star in front of that entry and reload the chunk server, it will empty that directory. So just wait until all the chunks are moved to a different safe place, and when it's moved, you just switch it off. So shrinking is very simple.
Can the check servers be not reliable against time and
Yes, unless you have a goal of 1, then you're out of luck. So if you don't have replicas set, then as long as you have set your goals so that you have enough replicas, yes, it will automatically create new chunks to the next available space. If you have that.
how well does the system handle the fact that a certain check server might die? Is it dynamically enough so that it doesn't matter and it just forget about the reference stuff? But suppose that you have enough replicas so that the probability of losing data is
The only scenario that I have experienced in the last months where we had a problem that actually balanced itself out after a while, funny enough, was somebody took live disks out of one chunk server and shoveled them into another chunk server. That was tricky, but it still managed to delete old versions, start replicate stuff around, and it balanced itself out. I was pretty surprised that it managed to do that, but it did. So it's pretty robust. I was looking if anybody has any other questions. So yeah, we run, like I said, on nearly everything. I personally have tried BSD, CentOS, Debian, Solaris. What else? Oh, I have a server and a client on the Mac. There is a commercial Windows client for people that insist on that operating system. I don't think that there is any platform that we couldn't support. I know that there are people running it on ARM. There's a relatively small community for that. There's one university in Germany that wants to set up a rather large ARM scenario. I'm pretty interested how that will work with the new 64-bit ARM. So if you have any other adventurous Unix-like operating system you would require LizardFS on, we can port that probably as well. The FreeBSD port took about 3 hours. Yeah. So let me just show you. I'll just connect the demo computer. I basically created a very small setup to show how a LizardFS just gets set up in minutes. Yeah. I just have to wait for the network to wake up. Does that fit? So I basically set up a couple of containers in Proxmox. Just to show a fast setup. So all I basically do is...
Can you invert the terminal code?
I try. Just have to get that back. I don't remember how you invert it, but I can at least make it bigger. And that won't help. Yeah, but now I don't know where the terminal is. Here.
Okay.
Okay. So is that readable?
Yeah.
Cool. Yeah, so basically we hard-coded some stuff. If you don't set a name for the master server in the configuration files, it will assume that it's called MFS master. So all you have to do if you want to do a fast setup is put MFS master in your host file and point it to the IP of your metadata server. Right? So basically the MFS master entry sets it up. So yeah, there's one thing I didn't talk about. That you can define a topology of your storage scenario. You can set which chunk servers should be preferred by which network segment. Right. So that way, if you have a large, complex network infrastructure, you can make certain clients just talk preferably to certain chunk servers. We have a customer that has a large rendering farm with a pretty chaotic network structure, and since they are trying to keep copies of all the data on all the chunk servers so they are close to the rendering nodes, they use topology to basically have one client always talk to one chunk server. So what I basically do is I just copy the sample files from the packages . And I don't change anything. I have to create an empty metadata file. And can just start the metadata server. So can just check on the browser. I don't know. Let's get this one again. Yeah. And we have a very simple web interface that basically lets you monitor the stuff. On that resolution it's a bit limited, but you can see you have a started metadata server, you can see how much RAM it has, how much RAM it occupies. all the metadata is kept in RAM while it's working. So the amount of files you can store in the LizardFS system is basically limited by the amount of RAM you put into your metadata. Yeah, so we have a metadata server basically running. I will attach 2 chunk servers to it, which is also quite simple. So it's just one package. It's called LizardFS chunk server. I have created a directory for the chunks. It's called LizardFS1. And I have 2 files to configure for that. One is basically telling him where he can find it. And the other one is a configuration file where I can keep the default values because I put MFS master into the host file. And you can see I have a chunk server running with 4 gigabytes of available space. So adding another chunk server is just doing exactly the same. And you can see in this example configuration file for the hard disk how you can remove a hard disk. You just put a star in front and it will just redistribute all the chunks to different storage spaces.
How do clients actually connect to the cluster? Protocol
We have our own protocol. It's a fuse-based client. We are working on some other clients currently. One is a native client for QEMU. That should be released pretty soon. Another one is an emulation interface for HDFS, so that you can connect Hadoop-like systems to it. And there is a plan to release an NFS conversion, so that you could locally connect via NFS, and it would speak Lizard on the network side.
Do you have plans to support multi-tenancy?
Multi-tenancy in which way?
Having different users that can mount shared storage with quotas and different users not seeing each other's files.
So we have a full POSIX implementation.
That's not the same thing.
And you can define rights for hosts per directory and per subdirectory. It's basically similar how you would do an NFS setup. So you define on the master which part of your namespace you want to be available to which clients, basically.
So the rest of the space would not be visible to other clients.
If it won't be totally visible, you can inhibit reads, but I don't know if it will not show you that there is a directory available. Okay, that's here.
Which database are you using for the data server?
Which database are we using for metadata server?
Well, we use no database, no data structures. Some other.
It's in-memory data structure created by us.
What language did you implement?
C++.
What's the performance like? If I have a rack full of high-end servers with 10 gigabit SFP links, is that something I can saturate?
It depends how many streams you have. Single speed currently is about 600 megabytes. The QEMU driver seems to be a bit faster, has about 750 megabytes in our last tests. But that's per single stream. So for example, if you would do KVM hosting, we usually do one mount per virtual machine, and each mount would have 750 megabytes. So yes, you could saturate it, but not with a single stream.
Is LizardFS a good choice for metadata heavy workloads like Mailbeers?
Like
Mailbeers.
like media.
Mailbeers, email storage.
If it's mail storage with single small files, not yet. It's like we said before, if it's under 64K, the file will not be split, so you will not really have distribution, and the performance would go down.
You mentioned you support snapshots. Are these on a file level or on the LizardFS system? Where does the snapshot occur?
Any object. Plus you can, one thing, yeah, I don't have the client now here, but you can change the policy with one command on any object. So you can set a goal of 2 now for your directory and change it to a goal of 3, just saying LizardFS set goal 3, and it will immediately start creating the next replica. So you can move from EC 2+1 to replication of 5 just with a one-liner, which is quite interesting if you want to do backups. If you have chunk servers that are defined as tape drives, you could just do a policy change on the directory and you would have automatic backups to LTO tapes. And you get it back by changing the policy on that directory with another line.
Do you have an idea of the ratio storage to remote?
Yes. Files, amount of files per RAM. I have a table, but I don't remember it. 1 second, I get you the table.
I can give an example. We're running it at a school as before, and we have about 50 million files, and it takes about 14 weeks to run.
Yes. Let me go here. So you have there's a client. The client has a config file where you basically define your mount point. If you want, you can also do it on the command line. But I can't type today anymore. And basically all you have to do is, if that directory exists, yeah. Again, it has to know where the MFS master is. If you use a different name for your metadata server, you have to set it in the configuration file. If not, it works right out of the box. And there's your directory. It's mounted. And actually, say we has a goal of 1, so there's only 1 replica. It doesn't really make sense to set a different goal now. I just have 1 chunk server, right? But setting a different goal would just be 2, 3, 5, 10 to that password, and it would distribute as many chunks.
So if you're just setting 1 chunk server with multiple copies of the same machine, what would you fail?
Would, yeah, and it would wait for you to add more chunk servers. So once you add a new chunk server, it would automatically start creating new chunks back.
When you restart the entire cluster,
Yes.
you do the metadata.
It creates it creates, it dumps the memory to disk every, Piotrek, how often do we dump the metadata to disk? Yeah, so we create one dump per hour, and you can set it up in the configuration to do it more often. Plus, you can create so-called meta loggers that will constantly log all changes to your metadata server. Yes.
What kind of integration tests do you run?
Integration tests.
That is, you deploy a server,
Yes.
multiple machines, use try-set before committing a patch to make sure that you use data and you can recover.
So
What kind of integration tests?
we mostly do load tests with any tool that I can find. I mean, it's like the test for 3.10.6 was like I had about 12 chunk servers and I was bombarding it from multiple streams with IOmeter, IOZone, and FIO at the same time, and then started kicking chunk servers out. I think for redundancy testing, that's good enough. Constant 100% load is always a nice test. There is nothing that you can do more than that, actually.
What methods can you use to make a metadata server highly available?
So we have members of the community that basically have tried it with. Yeah. We have our own system, but that's a commercial solution that we invented. That's based on the Raft algorithm. But it's your choice. Right? Yes.
So the mount point on the chunk server can be any file system, correct? Or
Yes, it's just a directory.
yeah, so is there any implication mixing different file systems?
No.
Some behave differently, performance-wise.
Okay, you have a performance impact on what you choose, but it will always be. In the replication, I don't see really a big impact if you use replication, but there will be a very big impact if you use erasure coding, because your writes are parallelized and you will always have the performance of the slowest chunk server in the write. Because the write will only be finished if all the chunk servers in that stripe set are done.
So were you doing tests with different file system types?
Yes. I actually have the same experience as the Ceph guys, that everything that starts with EX is not really a good choice. We have quite nicely worked with XFS, and for very high performance we have ZFS setups with all tuning that you can do there. With ZFS, your only limit is that you shouldn't fill your file system more than 80%, because then your performance goes like. Okay, I can answer any question, but after that, because time's up. Thank you.